To survive a dense forest, an autonomous drone has to process and identify every branch, shadow, and obstacle in milliseconds. Yet, before a model ever makes it into the wild, it faces a massive failure rate. 8 out of 10 AI projects die before reaching production, and the direct cause is usually poor data quality. As pre-trained architectures and open-source models become industry standards, the technical advantage shifts from the code to the inputs. By 2026, the proprietary, highly accurate labeled dataset you use for fine-tuning has become the primary defense against your competition. Modern annotation is incredibly heavy. Teams have to process a constant stream of text nuances, complex video frames, and dense 3D point clouds. Gathering that raw data is cheap and easy. Transforming it into structured, machine-readable ground truth is the true operational bottleneck for any machine learning team. To clear that bottleneck, you have to make a choice. Do you optimize for massive, high-speed dataset generation, or do you lock down the pipeline to prioritize extreme quality control and security? If you rely solely on fast, cheap labor or raw automation, you bake invisible biases right into the model. When your system suddenly hits an unexpected edge case out in the chaotic real world, it will fail. Let's map out the strategic landscape based on your data parameters. A basic sentiment analysis project sits down here, high volume, low complexity. But proprietary autonomous drone video sits up here, demanding rigorous security and complex spatial understanding. Their needs share almost zero overlap. To avoid systemic failure, you have to deliberately architect your pipeline. That means selecting the right software, applying the right automation, and hiring the right humans for your exact position on that map. Let's start at the base layer, the software you use to handle your raw data. You can deploy open-source tools like CVAT or labeling entirely for free. By skipping upfront licensing costs, you keep your cash burn low, but that savings is paid for in engineering hours. Your internal team will spend significant time configuring the tool, maintaining servers, and building out basic workflows. Alternatively, investing in a commercial enterprise platform like Labelbox, Scale AI, or V7 buys you immediate collaborative interfaces, bulk automation tools, and native API support right out of the box. This comparison table outlines the trade-off. Open source wins on upfront cost, but commercial platforms eliminate setup time and provide native 3D LiDAR support. But beware the commercial warning icon. You take on high monthly subscriptions and the risk of vendor lock-in. Your software choice determines how your engineering team spends their day. You have to decide if you want them building machine learning models or patching together annotation infrastructure. Once the software is in place, you must decide how much actual labeling to hand over to large language models and synthetic data. Using tools like GPT-4 or Snorkel for weak supervision allows you to instantly churn through the initial tagging of text blocks and basic images. It massively accelerates your baseline. The flaw here is that machines hallucinate. They miss subtle context cues, sarcasm, and complex visual overlapping. Left unchecked, automated labeling poisons your dataset. This workflow shows the required architecture for AI pre-labeling. The LLM handles the initial pass, funneling into a mandatory human review stage to establish consensus.
Zooming into human review reveals the core metric to catch errors: Inter-Annotator Agreement, or IAA. IAA works by assigning the same task to multiple human reviewers. If their corrections align, the label is approved. If they disagree, the system flags the ambiguous data for a senior expert to resolve. Integrating AI into the stack reconfigures your workforce. Human annotators shift from manual data entry into roles as high-level editors and quality assurance managers. This shifts the pressure directly onto your workforce. Who is sitting in the chair doing the reviewing? Building an internal in-house team gives you absolute control over domain-specific guidelines. It also keeps your data on your own servers, ensuring maximum security. But in-house teams are expensive to maintain. You take on high management overhead, and because annotation is deeply repetitive, you will constantly battle annotator burnout and turnover. Compare that to outsourcing the work to a managed global vendor. Vendors give you immediate access to hundreds of trained workers, unlocking massive operational scale overnight. The trade-off for that speed is a loss of direct daily oversight. If you outsource, you must rigorously vet your vendors for strict GDPR, CCPA, and ISO compliance to protect your users' privacy. Your labor strategy must map to your data sensitivity. The hard rule is simple: you cannot outsource what you cannot afford to leak. There is no universal one-size-fits-all pipeline. To make this work, you need to align your tool stack with your specific operational constraints. Let's look at 3 distinct scenarios. Archetype 1, the bootstrapped startup or academic researcher operating with a very tight budget. This UI card shows the required stack for this scenario: open source tools like CVAT, a small internal team, and entirely manual quality assurance. By keeping your cash burn near zero, you are trading time for money. Your scalability is severely capped, but your runway stays intact. Archetype 2, the scaling enterprise. You are handling massive volumes of e-commerce data or general tech feedback, and you need to move quickly. The scale stack requires a commercial software platform to handle the volume, LLM pre-labeling for speed, and an outsourced vendor network to manage the QA. Achieving this level of throughput requires high capital expenditure. It also means your internal engineers must transition into managerial roles, focusing entirely on monitoring vendor consistency and data drift. Archetype 3 is the high-stakes niche. This applies to defense tech, medical imaging, and financial fraud detection. The high-stakes stack demands highly restricted architecture. You need proprietary secure networks, subject matter experts working in-house, and zero third-party automation to prevent data exposure. For those in the high-stakes niche, the reality is stark. Achieving absolute compliance and protecting your intellectual property guarantees this will be the slowest and most expensive route available. Ultimately, building an AI pipeline is an exercise in high-speed, systematic sorting of complex information. The relentless hype surrounding algorithms often distracts from the truth. The rigorous, heavily manual groundwork of labeling raw data is what actually makes these systems functional. Choose the software, automation, and labor setup that matches your specific risk tolerance. Because at the end of the day, your machine learning model is only exactly as smart as the systems and the humans that taught it.